I think African American scientists need for success the same thing that all scientists need for success. A burning interest in what they're doing and the passion to work at it day and night. And to do that, you must really want to be a scientist. I grew up in segregated Birmingham, Alabama. My father was a high school teacher who had finished Tuskegee Institute, and he taught algebra and auto mechanics. My mother worked for the federal government. I wanted to be a scientist when I was about 12 years old. I was reading an article about Percy Julian, who was really my role model. He was also the first African American who was a member of the National Academy of Sciences. I think my upbringing was a catalyst because I was taught whatever you do it well and try to help other people get ahead. So it was not just the racism that I encountered, but it was a racism that I knew other people encountered too. I finished my PhD in the early 60s. And when I went to American Chemical Society meetings, I saw only one African American. NSB, or the National Organization for Black Chemists and Chemical Engineers, was started in the early 70s. What we conceived of at that time was to have an organization that we could address what we saw as the problems of getting more African Americans in STEM, to provide scholarships for undergraduate and fellowships for graduate students by leveraging our participation in government, industry, and universities. It still provides a pathway for people seeing other people who have been successful. It still, at the local level, generates more interest, science in the K through 12. My goal in astrochemistry is to study the reactions that explain our observations of comets and in planetary atmospheres. I'm working with a graduate student on a NASA grant to provide information about one of the molecules that we see in comets. I'm glad that the NSB chapter got reactivated. I am pleased that there is now a NSB chapter on this campus. It is open to all students of all races who agree to the principles of NSB, which is that we are dedicated to increasing the diversity and numbers of minorities in the STEM fields. The organization continues to grow and continues to open up its leadership to younger people going forward. They bring new energy and new ideas. The themes may be the same, but the methods will change with time.
It's important for the public to understand science and engineering so that they can be good citizens, so they can make choices. And I think by creating these videos, by talking about what engineering is, what it can do, maybe even what its limits are, that you help people make those choices. I think what I do is a fusion of an inheritance, if you will, from both parents. My mother was a botanist, but it was really her power of explanation that's the thing that I retained. The way that you open up a world to somebody that they haven't seen before. And then my father was a theater professor. I often went to rehearsals as a kid and watched him work. But what I really learned from him was craft. I wanted to reach out to the public. I wanted to explain engineering to them. And when I looked around, I talked to the University of Illinois, and they said they would create a position where I could come here, and in whatever way I wanted, I could reach out to the public.
So at the low end of the market, the VHS machines were cheaper than Sony's Betamax.
And I started in public radio. I did several hundred pieces for public radio, how to think about engineering, about how it affects your world. They were really an extended definition of what an engineer is, what an engineer does. And it really honed my storytelling. The very first book I wrote was a small book called Why Engineers Need to Grow a Long Tail. And the second book was 8 Amazing Engineering Objects. When writing a book, we always think of a most general reader, somebody who is curious, and we try to bring them along to understand more science and the deeper engineering subjects. I run the channel Engineer Guy Video. It has a little over 1 million subscribers and some 60 or 70 million views now.
The engineering in this, a modern disposable diaper, stuns me.
And in it, we just discuss the things that interest me and fascinate me.
The ingenious design of the aluminum beverage can.
The microwave oven, how it works.
This microwave oven is a truly remarkable feat of engineering.
Plastic injection molding, how they make all the plastic things that surround you. The Engineer Guy videos are shot in this room. This is my studio. I usually create the videos with students. Over the course of doing the videos, I actually became more appreciative of engineering. You want to make a contribution to the world, and I think these videos do that. I suppose, though, at the very root, I just enjoy creating them. I enjoy thinking about how you're going to explain something. I enjoy the challenge of it. So there's an aesthetic aspect to it that I enjoy greatly, and it drives me.
I'm Bill Hammack, the Engineer Guy.
Science is more and more a part of our everyday life. When I was growing up, science was not. Science is actually happening around you. It has an impact. You can't take that distant view of it anymore. H.G. Wells, when I was a boy, he had a big effect on my life. I was at camp, so I must have been around 10 or 11, and I read a book by H.G. Wells about a future world in which intelligent robots took care of making everything, and the people didn't have to work all day. And I thought, gee, that's a great idea. You know, it'd be like being in camp all year round. And when I finally met a computer, then I realized this is it. And that's basically why I joined IBM, because they had the thing that H.G. Wells was talking about, and I wanted to be a part of it. I joined the Navy because I didn't want to do theoretical math that only a few people could understand. The Navy did give me a chance to do really applied mathematics, and they didn't have anybody but me, as far as I can tell, who had a PhD in mathematics. It was just a life-changing experience. I started to work and learn about OR, operations research, and the techniques that are used in that. It's really just thinking mathematically about practical problems, and the world is full of them. And they had some Navy problems which they didn't know how to solve. I invented a method to solve them. But it turned out that method, which is called integer programming, has all sorts of other applications and became a very big thing. And they said, look, we've got mathematical ways to design a task force. It's a group of ships. It might be an aircraft carrier and a couple of destroyers, maybe a cruiser. What ships should go together with the right range and the right guns and the right aircraft? But the trouble is, using linear programming, the ships often come out fractional. And I said, it's about getting integer, which is whole number solutions, to linear programs. And they said, that's impossible. And that's why when I found a way to do it, It made a big splash, and suddenly I was well known. I wanted to go out where there were computers, which I felt were the wave of the future, and there'd be problems they wanted to solve. And so IBM's research division, which was just being set up, seemed like the obvious place to go.
In research, we work both on IBM products and on scientific understanding.
When I became the head of IBM Research, we were going to contribute to science and to IBM, because by contributing to science and being part of the world of science, that's how you get good people. A good one was the scanning tunneling microscope. A couple of our guys in our Zurich lab got the idea for making a totally new kind of microscope because we needed to know where the atoms on the surface of silicon were. It worked for silicon and it worked for everything else. And it ended up actually winning the Nobel Prize for Physics. I've always been an applied person. I've always wanted to solve problems in the real world. I want to have an effect.